In this screencast, I will demonstrate how to specify a system using PlantUML diagrams in FASTEN. PlantUML is an open-source tool allowing users to create diagrams from a plain text description. There is a wide variety of diagrams which are supported by PlantUML. Some of them can be modeled in FASTEN. To create system models with PlantUML diagrams, we need to go to New FASTEN Root node, System Models, PlantUML, and create a root node. Inside this root node, we can create various diagrams representing different views over the system architecture. Let us create, as an example, a use case diagram for a very simple pacemaker system. The actors interacting with the pacemaker are a doctor and the patient. Let us consider three use cases. The doctor programs the pacemaker. The doctor reads the history of the functioning of the pacemaker. The patient monitors the heart functioning. We can switch the presentation between displaying only the PlantUML text used to generate the diagram, displaying only the diagram, or displaying side by side the text and the diagram. Let us complete the model by connecting the actors to their corresponding use cases. The doctor programs the device and reads functioning history. The patient monitors the heart functioning. In the inspector window associated to a diagram, we can set the zooming factor and thereby scale up or down the picture. We can of course use more advanced features of PlantUML, such as adding notes to various entities, using colors and so on. Let us add a note that the program device use case requires more details. If we need special PlantUML features which are not supported by the current language implementation, we can use plain text fragments, which are translated verbatim to PlantUML scripts. For example, we can use special skin parameters for special display settings, such as displaying shadow on entities. Let us now create a component diagram for the pacemaker. For this, we create a new root node and add inside a node with the type A component diagram. Let us add some components and relations between them. A very high-level representation of the architecture of a pacemaker contains two components: the device itself and external components, such as apps used by the doctor to interact with the device. We create one component called pacemaker device, and this component contains several subcomponents: a sensor, electrocardiogram detector, generator logic, telemetry, battery, and the pulse generator itself. The external components contain, in our example, only the app. We can switch between different display modes, such as visualizing on the text, only the diagram or text and diagram side by side. Further, we can detail the communication structure between the inner components of the pacemaker device. The sensor sends information to the electrocardiogram detector. The rest of the communication structure can be further detailed in the model. The external component communicates bidirectional with the device. It is possible that we set properties of these components such color. Even if some PlantUML constructs are not supported, we can represent them as plain text. Let us, for example, use some special skin parameter for the diagram. We can go further and describe the interaction view over the system by using sequence diagrams. We create one or more root nodes to capture these interactions. Let us model the interaction needed by a doctor to read the history of telemetry data and reset the history. The doctor interacts with the device via the app. FASTEN supports a variety of constructs for creating sequences of interactions. Even if it is possible to create several diagrams inside a root node, we recommend to create one root node per diagram, such that the editor remains small and the diagrams easy to review. To sum up, in this screencast, we have demonstrated how to create a system model using PlantUML as every content models in FASTEN. Such system models can be further referenced from assurance arguments, from safety analyses, and so on. Thank you for watching. See you at the next episode.